everybody, this is Mrs. Pagan, and in today's lesson, our goal is to solve logarithmic equations, as you can see written above. Now, in example number 1, it says solve log base 3 of x plus 3 equals log base 3 of 8x plus 17. And what we want to do ultimately is get rid of the log base 3's so that way we can get x's by itself, and then it becomes a linear equation. Well, one way we can get rid of a log base 3 is if we exponentiate both sides with a base of 3. So I'm going to go ahead and make this a base of 3. Notice that I'm writing it pretty big because it is a base, and this log base 3 then kind of becomes an exponent actually of the base. And what we've learned before is a log base 3 and a base 3 cancel each other out. And same thing goes on the other side, and we are left with just x plus 3 equals 8x plus 17. And then it becomes an algebra 1 problem. We move the x to the other side, we get 7x here, and we move the 17 to the other side of the equation, and we get negative 14. And when we divide by 7, by both sides, we get x equals negative 2. Now, before I box it and say that's the answer, I do want to check our work because there could be extraneous solutions, which are solutions that don't work once we plug it in. So I am going to take the original equation. We have negative 2 plus 3 inside the parentheses there, and log base 3 of 8 times negative 2 plus 17. The left side of the equation, this is, by the way, our check, just so you know. The left side of the equation is log base 3 of 1, and the right side of the equation is log base 3 of negative 16 plus 17 is also 1. So it does check out, and therefore x equals negative 2 is a solution. And although you don't have to write this, boxing it it does indicate that it is a solution for us. All right, let's move on to the next example. As you can notice in example number 2, and let's compare to example number 1a. In example number 1, there's log base 3 on both sides, whereas in example number 2, there's only a log base 5 on one side. And in that case, we still want to get rid of the log, and one way we can get rid of a log is, once again, exponentiating both sides with the base of the log. So in this case, since it's log base 5, we're going to exponentiate both sides by base 5. So I'm going to go ahead and just put a big 5 there and a big 5 there. Now, this becomes a 5 squared. So these numbers, all values become exponents. So a base 5 and a log base 5 cancel each other out, and you're left with negative 3x plus 1 equals, and we know 5 squared is 25. Once again, it becomes an algebra equation. So subtract 1, we get negative 3x equals 24. And divided by negative 3, x equals negative 8. Now, I'm not going to box that. I want to make sure it works first before we continue. So let's check our work. We have, I'm going back to the original, as always, log base 5, and we have negative 3 times negative 8 plus 1 equals 2. So this is log base 5. Negative 3 times negative 8 is 24 plus 1 is 25 equals 2. Is that a true statement? Well, remember, this is another way of saying 5 to what exponent, or actually in this case, is 5 to the second power equal to 25, and we know that checks out, so therefore that is true. This is equal to 2. Therefore, 2 does equal 2. So I'm going to box that out. Oh, that's not our answer. X equals negative 8 is our answer. That just verifies that negative 8 works. All right, let's move on to the next one. Example B is very similar. We have log base 8. Notice how small that 8 is. Please write that very small on your paper. X minus 4 equals 2. And to get rid of the log base 8, we're going to go ahead and exponentiate both sides by base 8. And 8 and log base 8 cancel each other out, and we are left with x minus 4 equals, nothing cancels on the right side, but we are left with 8 squared, which happens to be 64. So we have x minus 4 equals 64. And x equals, when we add the 4 to the other side, it's 68. Now let's check to see if that's true or not, if it works or not. So the original problem, I'm just going to cross this off so I can see the original problem. Log base 8 of 68 minus 4 equals 2. Well, log base 8 of 64 equals 2 is what it reduces to. Now the question becomes, uh, 8 to what power is 64? Well, we know 8 to the second power is 64. Therefore, this expression is 2, which is a good thing because it does equal 2 on the right side as well. Therefore, x equals 68 is a solution, and it's not extraneous. All right, let's keep going. Here's some different ones. Now, let's kind of go back to the first example really quick. So in the first example, we had two log base 3's, and we basically exponentiated by using base 3 on both sides, and they both canceled. And in example number 2, there was only one log, and we exponentiated using the base of the log, and we got rid of the log, and it was fine. We went back to an algebra equation. In these examples, what you'll notice is there's two logs, especially in this problem, and even in the one that's coming up. So before we continue, what we want to do is use our rules of logarithms, properties of logarithms, to combine these two logs together. Notice that none of them have a little base number, so everyone should know that it's log base 10. And we know that if two logs are being added, it is the same thing as when we combine them as log of 5x times x minus 1. So it becomes a product equals 2. Well, we'll just kind of distribute this. So it's log of 5x squared minus 5x is what we're looking at, equals 2. Now, remember that a log has a base 10, so there's technically a 10 right there. So if I wanted to get rid of a log base 10, I would have to exponentiate both sides by 10. So this is going back to what we were doing earlier. These cancel out, and you're left with 5x squared minus 5x equals 10 squared. Although that little square looks really big, it is a 10 squared, and that is 100. All right, now we do have a quadratic in our hand, so I'm going to go ahead and move everything to one side. Set it equal to 0. And I do notice that they all have a 5 in common, so I'm going to factor out a 5, and we get x squared minus 1x minus 20 equals 0. And I'm going to see if we can factor this out. So I'm going to move it over to the side a little bit here. Here's a 5 we had out. Let's see if we can factor out the quadratic. Well, I know x times x is x squared, and I'm trying to look for a number that's going to add to negative 1 and multiply to negative 20. And I think 5 and 4 is 20, and negative 5 and positive 4 will meet that negative 1 need as well. So what we end up having is 5 equaling 0 does not give us a solution, but x minus 5 does equal 0, and when we solve for x, we get x equals 5. We also can do the same thing here. Let's write it out. X plus 4 equals 0, and therefore x equals negative 4. Some of you might have already seen those answers jump out at you, and that's great. Now, we're going to go ahead and input those values into the original to check. And since we have two solutions, we're going to have to check both. So right now, this is our way of checking x equals 5 to see if it works, okay? So we have log of 5 times 5 plus log of 5 minus 1 equals 2. Well, this is the same thing as log 25 plus log 4 equals 2. Alright, I'm going to use my calculator to figure out what these logs are really quick. So I'll move my calculator on this side. So we have a log button right here of 25, and I'm going to close that up, plus log of 4. And I'm hoping that this is going to equal 2, so that way, and it does. All right, so it does equal 2, and that's a good thing. And therefore, we know that x equals 5 is a solution. Now, we do have to also check x equals negative 4. So we have log of 5 times negative 4 plus log of negative 4 minus 1 equals 2. So we have log of negative 20 plus log of negative 5 equals 2. All right, let's check on the calculator to see what happens there. We have log of negative 20 and close parentheses plus log of negative 5. And if we get a 2, then that means this is a solution. If we don't, it's not. And we are getting a non-real answer, which means this is not going to work. And part of the reason is because of the negatives inside the log. So we do get an error message when there's a log of a negative 20, because the question then becomes 10. This is the base 10 here. 10 to what power equals negative 20? And a power cannot make a positive number into a negative. So it creates an error. And since an error does not equal 2, we have to say that x equals negative 4 is not a solution. So the only solution we have right now is x equals 5. Therefore, x equals negative 4 is extraneous. All right. Let's do that one more time, see how it goes. So let's get to this other one. All right, once again, as you can see, we have a 2 logs again. We want to make them 1 before we continue. So because there's a plus sign, we're going to go ahead and multiply those logs. So we have log base 2, and we're going to multiply x times x minus 7 equals 3. Now I'm going to go ahead and rewrite those. So log base 2 of x squared minus 7x is what we're looking at. And now we have 1 log, which we know how to get rid of. If it's a log base 2, then we can go ahead and exponentiate both sides by base 2. And we're trying to be fair. That's why we have to do it on both sides. So log base 2 and base 2 cancel each other out, and we're left with x squared minus 7x. And 2 to the third power is 8. When we move everything to one side, because it is a quadratic, we get the following. And now we want to see if we can factor it out. We get x times x is x squared. We have 8 times 1. There we go. So we have a negative 8 and a positive 1 to meet the needs of the negative 7. And our solutions are x equals negative 1, once you set each one equal to 0, and x equals positive 8. Ooh, and I boxed them thinking they're both the solutions, but I'm going to unbox them because we do have to check them, make sure there's no extraneous solutions. All right, so let's look at the first one. Let's check x equals negative 1. We have log of base 2 of negative 1 plus log base 2 of negative 1 minus 7 equals 3. And I'm going to stop right there and say this is going to be an error again, equaling 3, because we have a log base 2 of a negative number, so it's not going to work. Therefore, this is not a solution. And we dealt with a problem similar on top here. All right, we have x equals 8. Let's see if that works. It can maybe not work, but we'll find out in a second. Ooh, I'm sorry, that's a plus sign. Log base 2 of 8 minus 7 equals 3. So I'm going to go ahead and take out my handy dandy calculator. Let's put this in. We have, we have a base 2, so we're not going to use a calculator. Let's do that by hand. 2 to what power is 8? Well, that's a 3, plus this becomes log base 2 of 1. 2 to what power is 1? Well, 0 power will do that, equals 3. Therefore, 3 does equal 3. And since that checks, we know x equals 8 is a solution. All right, I want you to write this problem down. We are going to go over this tomorrow in class. I will see you then. Bye.